Hello, everyone. It is my pleasure to introduce our research on a wideband dual circularly polarized series fed corner-truncated patch array using coplanar proximity coupling. The geometry of the proposed wideband proximity coupled series fed dual CP antenna is shown in this figure. It is composed of a cross-shaped arrangement of corner-truncated patch array serving as the radiator, a folded microstrip line, and two tapered microstrip lines acting as the feeding structure, and a soft surface structure for radiation pattern improvement. Compared with the existing works in series fed dual CP antenna designs, the contributions of this work are summarized as follows. First, the corner-truncated patch array is for the first time used in designing an proximity-coupled series-fed dual CP antenna. Besides, it effectively resolves the problem of narrow operating bandwidth for the previous single-layer series-fed dual CP antennas, while maintaining a high antenna efficiency simultaneously. Furthermore, the proposed antenna achieves stable boresight radiation across a wide operating bandwidth, effectively mitigating the common beam deflection issue in previous coplanar single-layer series-fed dual CP antennas. Compared with the existing series-fed dual CP designs, the proposed design achieves attractive features of simple structure, wide operating bandwidth, high antenna efficiency, and low cost. This page shows the design evolution and operating mechanism of the proposed antenna. At first, the proximity-coupled series-fed technique has been introduced for the boresight dual CP operation at a lower operating frequency, which is indicated as antenna 1. Then, we introduce the inner patch group and corner truncation, which are indicated as antenna 2 and antenna 3, respectively. By this way, the coupled power for the four outer patch group elements becomes more balanced, as shown in the figure of current density distribution. Thus, the operating bandwidth has been improved in antenna 2 and further in antenna 3. At last, in proposed antenna, a soft surface structure has been incorporated to improve radiation pattern at a higher operating frequency. When utilizing the soft surface structure, the surface electric field is predominantly confined within the structure itself and exhibits a relatively uniform distribution. The proposed wideband proximity-coupled series-fed antenna has been simulated, and a prototype has been fabricated and measured. Here are the simulated S parameter and axial ratio when port 1 is excited, taking into account the 10 dB impedance bandwidth, 15 dB isolation bandwidth, and the 3 dB axial ratio bandwidth. The operating bandwidth of the proposed antenna is 18.5% in experimental measurement. The radiation performances of the antenna are shown in this page. It can be seen that the proposed antenna maintains stable boresight CP radiation characteristics at the three frequencies across the operating band. Across the operating band, the measured realized gains range from 6.82 to 8.48 dBIC. The measured total efficiencies range from 74% to 85.5%. More details can be found in the references. Thanks for your listening.